For this project, we're in charge of robot development and the Arduino programming. As you can see in this robot, there's lots of sensors and motors, which all have to work well together, and all this is done through the Arduino programming.
So in the Arduino programming, the calibration of the sensors and motors are essential so as the robot functions well. The program also incorporates left-right turn, straight-forward motion, and calibration to ensure that the movement of the robot is well.
All these movements are then passed on to the algo to ensure that the robot then achieves the goal.
The algorithm is the soul of the robot, as it helps the robot explore through the maze as well as determine the fastest path in order to get from the start point to the end goal. The exploration algorithm uses the left wall following algorithm, which allows the robot to follow the left wall from the start point to the end goal back to the start in order to determine the maze and the obstacles in the maze itself.
So for the fastest path, we'll be making use of the A-star algorithm to ensure that our robot completes the maze in the fastest time possible.
For this project, we are in charge of the Raspberry Pi. Raspberry Pi serves as the main communication hub. Any communication between the Arduino, Android and PC are all transmitted through the RPi.
RPi is also responsible for image recognition, where it captures the image attached on the obstacles and sends it to the FRCNN model for detection and recognition.
So the Android Remote Controller Module, or also known as ARCM, is meant to provide the user a good interface to control the robot. One of the things that the ARCM allows the user to do is to control the movement of the robot. We can make the robot move forward, turn left, as well as turn right. Aside from that, the ARCM allows the user to command the robot to start exploration as well as commence fastest path. To do this, all the user has to do is set the start point, set the waypoint, press explore or fastest path button to start exploration and fastest path respectively. As the robot explores the maze, the robot will take pictures and perform image recognition on the images taken, and the algorithm will send the coordinates and the image ID for the Android tablet to display.
The ARCM is also equipped with two configurable buttons called F1 and F2 that allows the user to customize the commands to send to the robot. We have also decided to create a debug page in the Android that will help the Arduino micro team calibrate the robot before the launch. We have decided to implement the tilt sensing using the Android tablet's built-in accelerometer sensor. The user will first need to activate the tilt sensing using a toggle button and set the robot controls into manual mode, and by tilting the Android device, the user will be able to send commands such as forward, turn left and turn right to the robot.
So it's what? The Group 10 exploration round.
1, 2, 3.
This time? Holy shit!
Is that a bit off?
No, it will get stuck.
Deja vu, I just been in this place before. Higher on the street and I know it's my time.
Hello Gabby.
Hi.
What just happened just now?
So our robot failed the full exploration, but it's okay. We still have 3 more weeks.
Okay, group 10, fastest path, now.
MDP is the most memorable project in SCSE.
Through MDP, I made many friends.
Thank you,
Thank you, MDP Group 10.
Thank you, MDP Group 10.